Hey guys, welcome to the Comporium. I had a couple of requests to talk about metal lathe that we had in our shop. So today I was cleaning out this corner of the shop and I just thought I'd kind of show you what the scoop was on this old girl. It's a pretty neat old lathe. This is the only plate I could find on this lathe. It's a South Bend. I couldn't find a date on it anywhere. These are just gearing ratios for the stud and the lead screw, telling you how to swap things out so you can cut different threads per inch on it. But yeah, I can't find a date. There's a flat belt and there's a counter shaft on it. And I think it's been a homemade dealie, but it works pretty good. There's a lever on the side that locks everything tight there. And then when you push the lever up, it loosens the belt off and you can change the speeds depending on what you want to do, just that quick. And then tighten the belt back up. So this lathe is a strange combination of being really big and not being really big. The bed length is about 96 inches, so it's got an 8-foot bed. And looks like it'll take a 6-inch radius, or that'll be a 12-inch swing. And I'll check the distance between centers in a little bit here. So aside from the bed being really long and the swing being okay, then you start getting into other things. A lot of lathes, there's a hole in here that's quite a bit bigger than this. I think this will accept about 5/8 material. I don't think a 3/4 will go all the way through. And I've got a nice big 4-jaw chuck in there now. And the headstock and the tailstock both have number 3 Morse tapers in them. I'll show you what they look like. So to get the tapers out of the tailstock, you crank the handle back all the way and it kind of hits a stop. And then it bumps the taper out of the socket. And this is a number 3 Morse taper adapter. On the bit. The bit itself, I believe, has a number 2 Morse taper. It's just fit in this. This is just takes a smaller taper, so it'll fit in the bigger taper hole. I'll show you a couple of tapers on the bench here. So this is the bit we just took out of there. You can put a piece of flat stock in there that's tapered, and you can just give it a tap, and it'll release that the drill bit from the taper adapter. This is what the drill bits look like without the adapter on them. And so this is kind of a rusty, but this is what we got. This is a number 3 Morse taper. It's just a dead center. And this is a newer one that I bought at some point with a number 2 Morse taper and a threaded end on there. It probably will accept a Jacob's chuck of some kind or other. But yeah, those are just some different tapers that we have kicking around for this lathe. That's a number 3 Morse taper in the tailstock there. This lathe came to me through a neighbor who's had a family member who was downsizing to move into the lodge or had gotten sick or something. Anyways, the lathe was gifted to them, and it was so big and he really wasn't into machining. He didn't really know what to do with it, and it wasn't going to be very politically correct or family wise to sell it. So it was just taking up space, and I seen that he had it, and I said, hey, do you want to sell that? And he said, well, I can't really sell it because it's his family members and there'd be hard feelings and stuff. He says, but I could store it at your place and you could use it. And if you ever go to sell it or something, you've got to let me know what's going on. But that was 30 years ago, and he might even have forgotten that I have it here. But anyways, it's still here and I use it. It's by no means in spectacular shape. You can see pieces of the cast iron have been, knocked off of there. And underneath the chuck, there's a whole bunch of apprentice marks. Somebody's taken the chuck off without putting down something properly to keep it from dinging up the ways. And there's a fair bit of wear in the ways and in the cross slide. And I had to do a fair bit of work to it just to get it so that it was even remotely usable. One of the things I had to do, this long threaded screw here is part of the cross slide. It hooks on to this and it moves the cross slide back and forth. When you take that shaft out of there, this is what it looks like. This is the end that the handle's on, and then there's a smooth part that just kind of runs in there, kind of just steel on steel, like almost without a bushing. And I believe the gear on here is for a power feed for facing on the cross slide. And then this is, I believe it is a 5/8, 10 threads per inch, left-hand thread. This is a 5/8, 10 threads per inch, left-hand thread. What makes that unique, aside from it being a left-hand thread, is 5/8 coarse threads are, national coarse threads are 11 threads per inch, not 10. And the reason for that is, the left-hand threads on lead screws is intuitively, if you put right-hand threads on the lead screw, every time you go to turn it, you're going to turn it the wrong way. Your brain's just hardwired that that's not the way it should be. So most lead screws have left-hand threads on them to advance and to bring your tool back when you're working them by hand. And the reason for 10 threads per inch is that there is a graduated markings on. You can see there, I'm trying to get it to focus on there. Come on, focus, there we go. You can see it's graduated here, so you've got 100 thousandths of an inch, or a tenth of an inch per turn. So when you advance a 10 thread per inch lead screw one turn, it goes 100 thousandths of an inch forward or back. So I wasn't going to be able to find one of those at the parts place, that's for sure. One of the problems that came with the lathe, this is the part that attaches it to the cross slide, and this threaded portion is 10 threads per inch, left-hand thread, 5/8, and it's worn enough. I don't know if you can hear it, but I can push on this hard enough to actually pop this threaded part right through. There's quite a bit of play in there, and this will actually strip up and down about, if you hold it just right, about 3 or 4 threads. And you can see how much play is in there. And so it was functional at both extreme ends of the lead screw, but in the middle, it was just ready to pop all the time. So doing fine work with it was next to impossible. So my very first machining job was to make one of these new lead screws with the lathe. So that was fun. I had to do a lot of stuff to get that figured out. The lathe came with this homemade kind of milling attachment here that bolts right on to the cross slide. And I knew from the little bit of playing that I'd done with it that I wanted a longer lead screw. The old lead screw only came to about here, so I made it about 6 inches longer so that I had more back and forth. As it turns out, there's just about enough play in that thing. I shouldn't have even bothered with the milling attachment, but that's what I did when I made it anyway. I had all the gears here to set it up to cut the threads, but I needed to be able to cut a left-hand thread, and I needed to be able to reverse my motor, and the motor on it just had a regular switch. It only had forward. This came off of a conveyor belt that we used to load bags of fertilizer. It's just a reverser, and there was a 1/2 horsepower motor, so I robbed the 1/2 horse off of the old conveyor and the reverser switch. So I was able to run this thing forward and backwards. Modern lathes, the ones I'm familiar with, come with gearboxes, so you just have to set it in whatever gear setting you need to cut different pitches of threads. But this old girl came with a pile of gears, and you got to do a little bit of math. But all of these gears, it's hard to see in this light here. There's a number stamped on each one that tells you how many threads are on each, or how many teeth are on each gear. And you can set up all sorts of different gear trains on this to cut different threads. But the lathe, when it came, it only had the forward one of these. So my next thing was I had to build a fly cutter and make a gear. So that's what I did. I made a fly cutter and I made another gear so that I could forward and reverse this lead screw feed. So you've got a forward and then just turn a little bit there for reverse. So if whichever one you want it in, and you tighten this down, you can see back in behind this big guy, there's a slot there so that you can do all kinds of messing around to get your gear train right. And it takes a little bit of math to get it, but it's all just the old way they used to do things here. So I'm going to engage the lead screw here. I don't remember offhand how our lead screw is set. So it'll just advance at whatever our setting happens to be set at there. So, we'll forward gear. The lead screw's turning. This is the half nut here. When we engage this, our carriage should move forward. You see our carriage is advancing under power at whatever gear ratio we've selected. I just don't know what it is offhand. And then we can disengage it whenever we want. Stop it. And you can crank it forward and back. So then we can put this the other way and it'll reverse the direction of the lead screw. And now our lead screw is going the other way. And we engage it. You can see that it's moving in the opposite direction. At some point, this thing had been hoisted and dropped, or something bad had happened. This had broke, and so somebody has brazed that up, and there is just a little bit of a wobble in the lead screw. I had the lead screw out, and I put it in the press with a dial gauge on it, and I did everything I could, but I just kind of chased the wobble back and forth. I never did get it dead straight. So there's a little bit of play in all of this, but that actually makes the carriage run a little bit smoother, having a little bit of play there rather than having everything too tight. Most common reason for me to engage the back gears is to change the chuck. the chuck is screwed on here, so we engage the back gears, and then everything is solid tight there. And you can take your T-wrench and break it loose. This will also come off if you go from forward to reverse without stopping everything, and it's pretty catastrophic. This big heavy chuck will go flying across the shop, make a big fat mess. So with these threaded ones, it's a good idea to not do that. Just going to change the chuck out here. Put a board down to keep from damaging the ways. This is a 3-jaw chuck. So for slower speeds, you turn this, you can see there's a square pin right here. So we can loosen that off and move it either forward or back here. I think that's the right way. Push it down. Let's go the other way. Oh, that's right. So now with the back gears engaged, you can see that we've got a lot lower gear ratio happening here. So I'll turn it on. And there again, we can loosen off our belt and change speeds. That's probably as fast as you ever want to run that thing. So we'll put it right back onto our direct gear drive here, or direct belt drive. Disengage the back gears, and there's a slot that this has to line up in. We'll find it. Let's give this a turn until it locks in solid. Give it a little tighten. These are the kind of tool holders I learned how to use when I was in school, about 35 years ago. There's a right, a left, and a middle. And there's a tool post holder, the thingy there. And this is a boring one with a boring bit inside for doing inside diameters. And there's a tool holder with a bit inside it. These are high-speed steel. I have some carbide tools and carbide inserts, but this lathe is old enough that when there's so much flex and just a little bit of vibration that if you try and use carbide, they just crumble. It's crazy. You can only use high-speed steel in this light lathe because it will just fall apart if you try using carbide, which is too bad, but high-speed steel will do all kinds of stuff if you just don't get in a hurry. So for this kind of work, you want the tool mounted at center or just a little bit below. For cutting threads, it's supposed to be right on dead center, but we're just gonna take a light pass on this just to cut something. So a piece of shim stock in here, some kind or other, and we can push against it to kind of find center. When it's straight up and down, then we should be right on center. And if it's higher or lower a little bit, we'll just set it so we're just a little bit below center. Yeah, right there's good. Try and keep our overhang to a minimum so we don't have chatter. That's not the right handle for that. Guess I needed the number 9. There's a number 9, whatever that means. I changed my angle a little bit there. The old girl can still make chips. Yeah, it's a reasonably good surface finish. That's just a high-speed steel bit, not even particularly sharp. And we just took a little bit off there just to show you that this girl can still hold her own when it comes to doing work. These nice long curly cuttings, and there's no discoloration on them either. It's cutting it nice and cool. I don't have any cutting oil, I just use regular oil on there, which isn't the best, but that's what I had. So I learned on these kind of tool holders, but I ended up building kind of a turret type deal. So I can put 4 different kinds of bits in this thing and then easily swap them out. I'll take this one out and just pop that turret one in there. So I actually made this tool holder on the lathe, and if you have ever taken a lathe and made a cube on a lathe, that's a pretty cool project to know that you can make something square on a lathe. That's a whole other video, but anyways, you can see the different tools go in here, and you can just tighten it down, and then once you got your height set, you just loosen this off and give it a turn, and then you've got another tool ready to go. And I just have it set up so that I can use different size high-speed steel and shim it however I need to, depending on what kind I'm using. And yeah, it works the same as the other kind, but it's a lot less fiddly, but it's bulkier. You don't have as much, you got a little bit more flexibility with reach with those other ones for reaching into tough places that you don't with this block. But it's pretty easy to swap out. They just slide out of there. Some of the other stuff that came with this lathe, there was an assortment of tapered bits, mostly number 2, but with a number 3 adapter. This one, that's a number 2 to a number 1 adapter. I just found that. I didn't know I had it. It was rolling around in the bottom of the drill bit thing. There were a couple of lathe dogs that came as well. I use this for holding material to turn between centers. It's a pretty skookum one, this one. This steady rest came with it, and I built this other one here. I had a couple of brass pieces that mounted in there, and that clipped onto the this steady rest follows the work that you're working on. I used it for threading that really long cross slide when I was threading it to keep it from springing in the middle. And it's a Jacob's chuck with a number 3 Morse taper that'll fit in the headstock or the tailstock. Another interesting thing for cutting tapers is there's a couple of set screws on the side of the tailstock that you can adjust, and it's really hard to see it, but there's a line on there, and you can adjust this back and forth for cutting tapers if you want to cut a tapered piece in between tenors. This is graduations on the front of the compound rest. So you can turn the compound rest. To turn the compound rest, there's a couple of nuts on either side here. You can loosen those off, and then your compound rest will slide to whatever degree you want. And there is a line right there. I'm always going to put a light over this lathe, and I just have never got around to it. As I'm getting older, it's getting harder and harder to see when I'm working on it, so I think a light is in order. If you have an old metal lathe, one of the first things you should find is a copy of this book, How to Run a Lathe. It was published by South Bend, and it has all the information in there on how these old girls work. And I mean, everything in here is analog, but if you have one of these, there's just about nothing that you can't make happen. There's a picture there. That is almost identical to the lathe I trained on when I was back in school, except the one we had a cooling pump with coolant and a chip pan so that you could run coolant onto your cutting tool all the time while you were cutting. But that was almost exactly what we were using in high school, which is pretty cool. No digital readout on that. You just had to squint. But yeah, this book is just full of all sorts of good stuff on how to run these old machines. And let's see, 1966 was the last date in the copyright here. I know these are still available. You used to be able to buy reprints of them, and I see that some of these on here, that's SAIT, which is the technical college in Calgary. That's the SAIT bookstore where this came from, for $3.60. You can't buy anything for $3.60 anymore, so that tells you how old this book probably is. I've probably made this video long enough. I just kind of wanted to give you a quick rundown of some of the stuff that this old girl would do and show you what it still can do. And yeah, I could talk on this subject for hours. It's a hobby of mine. I'm not a machinist, I'm a farmer. My training in technical school was actually welding, but machining is fascinating to me, and this has been a lot of fun having this thing around, and it's saved me some money the odd time. And yeah, anyways, if you happen to know anything more about this lathe, or like any information that I don't have, because I really don't know how old it is or any more about it than what I've told you, please leave that in the comments, because I'd love to hear more. And yeah, thanks for watching.